Good day everyone, we are the group 2 and we discuss the circuit breaker and the principal, parts, and also applications. First, what is circuit breaker? A circuit breaker is an automatic electrical safety device designed to protect an electrical circuit from damage caused by overcurrent such as overload or short circuit. And also, a circuit breaker is like an automatic safety switch that cuts off electricity when the current becomes dangerous. To make it short, a circuit breaker does not just turn off electricity. It automatically detects danger and interrupts the current in milliseconds to protect wires, appliances, and people. Based on the image, we can already understand its basic working principle. The red path represents the flow of electric current through the circuit. The coil wrapped around a soft iron core acts as an electromagnet. The spring mechanism is responsible for opening the circuit when needed. The contacts, or yung where current flows, are the points that connect and disconnect electricity. How it works. If normal operations, current flows smoothly through the wire shown by the arrow. The contacts remain closed, allowing electricity to pass. The coil produces a small magnetic field, but enough to trigger anything. The second one is overload or short circuit occurs. The current suddenly becomes too high. This high current strengthens the electromagnetic field in the coil. The third one, if the magnetic force activates mechanism, the strong electromagnet pulls a mechanism or link to the spring. This action releases the spring-loaded switch. The fourth one, circuit breaks or trips. The spring quickly pulls the contacts apart. This stops the current flow immediately, preventing damage or fire. Other explanations for easiest way to understand this diagram, the diagram shows how current flows through the breaker. The contacts allow electricity to pass when closed. The coil acts as an electromagnet when current flows. If current becomes too high, the magnetic force increases. This triggers the spring mechanism, which opens the contacts. Once the contacts open, the circuit is broken, stopping electricity. To elaborate some topic, I will introduce to you my other group members to explain more and to give some details about the circuit breaker. To better understand, let's listen carefully.
Before, the main protection device used in electrical system was the fuse. The fuse works by using thin metal wire that melts when the current becomes too high, which stops the flow of electricity. However, once it melts, it cannot be used again and needs to be replaced. As technology improved, circuit breakers were developed. Unlike fuses, circuit breakers are reusable and do not need to be replaced by day trip. They are also faster and more reliable in detecting electrical faults. Over time, circuit breakers have improved a lot. They become automatic instead of manual, more accurate in detecting problems, and provide better protection against overload and short circuits. Modern circuit breakers can even connected to smart system for better monitoring and control. Circuit breaker works by continuously monitoring the flow of electric current in a circuit. When it detects abnormal conditions such as overload or short circuit, it automatically cuts off electricity to prevent damage. Inside the circuit breaker, there are mechanisms like thermal or magnetic trips. There are components activate when the current needs a safe level, causing the breaker to open the circuit. In example, the process is first it detects excessive current when it activates the trip mechanism and finally stops the current flow. This helps protect electrical devices and wiring from damages.
Hello everyone, I'm Nathaniel Razon from 3EED. Main parts overview, core components and functional architecture. To provide a high-level architectural overview of the circuit breaker's anatomy, establishing the relationship between the mechanical, electrical, and protective system for detailed analysis. The 5 essential systems. A modern circuit breaker functions through the synergy of 5 critical subsystems. Understanding these building blocks is the key to mastering the device operation. Number 1. Contacts. The primary current carrying interface. It is typically consisting of fixed and moving contacts. Their design determines the continuous current rating and the ability to withstand short-circuit currents without welding. Number 2. Arc extinguisher. The arc management system. Located just above the contacts, when the contacts spark during a fault, an arc forms. This assembly splits, cools, and elongates the arc until it is safely extinguished at the natural current zero. Number 3. Mechanism. Operating mechanism. The muzzle and the skeleton. The mechanical linkage and spring assembly that dictates the speed of contact separation and closure. It ensures consistent make and break operation regardless of how fast the operator moves the handle. Number 4. Trip unit. The brain or intelligence. The sensing and decision-making component. It is monitors current flow and signals the operating mechanism to trip when it detects overload or short circuits. In electronic version, it offers adjustable protection curves and communication capabilities. Number 5. Insulation, or the safety barrier. The dielectric system that isolates conductive part from each other and from the operator. This includes housing materials, arc chamber, walls, and barriers that ensures the device can withstand transient voltage spikes without flashover.
In the context of a circuit breaker, the contacts act as the gatekeeper for electricity. The contacts are the most critical conductive elements of a circuit breaker. Their primary function is to maintain a low resistance path during normal operation and to physically separate to interrupt current during a fault. Types of contacts. A typical circuit breaker assembly consists of two distinct types of contacts that work in tandem. The first is fixed contact. This part remains stationary within the breaker housing. It is connected directly to the incoming or outgoing power bus bars. It provides a stable surface for the moving contact to press against. The other one is the moving contact. This contact is attached to a mechanical linkage, often a spring-loaded or pneumatically driven. It moves physically to either touch or separate from the fixed contact, thereby making or breaking the circuit. Its role in current flow. The primary job of the contacts is to provide a low resistance path for electrical current during normal operation. When it comes to continuous conductivity, when the breaker is on, the fixed and moving contacts are pressed together under high pressure to ensure maximum surface area contact. Meanwhile, when it comes to heat management, they must be able to carry the full rated current of the circuit without melting or overheating. If the contact surfaces become pitted or dirty, contact resistance increases, which can lead to equipment failure. The opening and closing action. The mechanical movement of these contacts is designed to be extremely fast to protect the electrical system. Closing action or making the circuit. The moving contact is driven toward the fixed contact at high speed. Rapid closing is necessary to prevent pre-arcing or sparks jumping the gap before the contacts actually touch, which can weld the contacts together. The opening action or breaking the circuit is when a fault, like a short circuit, is detected. The breaker trips and a spring or pneumatic system pulls the moving contact away instantly. As they separate, an electrical arc forms across the gap. The contacts must be designed to withstand this intense heat until the arc is extinguished or quenched by the breaker's internal insulation like air, oil, vacuum, or SFX gas.
What is an arc? An arc is a flash of electricity that happens when two contacts in a circuit breaker are moving apart. Usually, air does not let electricity flow through it. When arc happens, it gets so hot that air between the contacts turns into a special kind of gas called plasma. This plasma is made up of particles that can carry electricity. Because of this, the electricity keeps flowing through the air even when the metal contacts are not touching each other. Why does it form? When a circuit breaker is told to open while a lot of electricity is flowing, the contact starts to move. This is when the arc forms. It happens because of two things that occur in a short time. Field emission. When the contacts first start to move apart, they are still very close together. Thermionic emission, ionization. The large amount of electricity flowing through the space between the contacts get very hot. This heat makes the air particles around move violently and knock tiny particles called electrons. Arc quenching methods. There are two ways to stop an arc. High resistance method. This method makes it harder for the electricity to flow through the arc so it eventually stops. Zero current interruption. This method waits for the moment when the electricity flowing through the arc is zero and then it quickly removes the gas so the arc cannot start again. Practical quenching techniques. There are ways to stop an arc. Arc splitting. The arc is pushed upwards into a series of metal plates which help to stop it. Lengthening the arc. Moving the contacts apart makes arc longer which makes it harder for the electricity to flow through it. Cooling the arc. Blasting the arc with a high pressure gas or pushing it against a surface helps to stop it by removing the heat. Using specialized dielectric mediums. Vacuum. Removing the air completely stop the arc from forming. SF6 gas or sulfur hexafluoride. This special gas captures the electricity particles that carry electricity which help to stop the arc. Oil. The contacts are separated inside tank of oil that helps to stop the arc. In short explanation, an arc is a flash of electricity that happens continues to flow even after contacts in a circuit breaker separate. This happens because the air between contacts becomes plasma due to extreme heat, allowing current to pass through it. An arc forms when a circuit is opened while current is still flowing. As the contact move apart, electrons are released, field emission, and intense heat causes the air to ionize, thermionic emission, creating a conductive path. To stop the arc quenching, two main methods are used: increasing resistance so current cannot continue, or interrupting the current at zero flow. In practice, this is done by techniques like splitting the arc, lengthening it, cooling it, or using special materials like vacuum, oil, or sulfur hexafluoride gas to extinguish it quickly.
This is a circuit breaker. It is used to protect electrical circuits from damage caused by overload on short circuit. When the breaker is on, electricity flows normally through the circuit. Where there is an overload or fault, the breaker automatically trips and switches off to stop the flow of electricity. This simulates the tripping action of the breaker. After the problem is fixed, the breaker can be reset by switching it back on. A circuit breaker protects electrical systems by automatically interrupting current during fault.
Two types of trip unit. Thermal trip. This mechanism protects against overload. An overload is a sustained current draw that exceeds the circuit's rated amperage but is not yet a catastrophic short circuit. It uses a bimetallic strip. As current flows through the strip, heat is generated. If the current exceeds the breaker rating, the strip bends. If the overload lasts long enough, the strip bends far enough to trip the breaker. Magnetic trip. This mechanism protects against short circuit or severe ground faults. This is when the current flow spikes to thousands of amps instantaneously. It uses an electromagnet, a solenoid, when a massive surge of current occurs. The magnetic field created is strong enough to instantly pull a plunger or armature, slamming the breaker open. So the difference between the two is pretty simple. Thermal trip, this one is all about overload. When you plug in too many things at once, like heater, microwave, a coffee maker, and all on the same line, the breaker doesn't trip right away. It's kind of hits up first, take its time, and then finally say enough, and then shuts off slowly. The magnetic trip, this one is for short circuit. That's when wire touch that shouldn't, like if a live wire hits a neutral, yun, mag-i-instant trip. It doesn't wait, it happens in a split seconds. You might even hear a loud snap when it goes. So the really main difference is one trips from heat, takes a while, the other trips from magnet happens immediately.
Circuit breaker insulation and housing materials. Material use. Circuit breaker are designed using strong insulating and protective materials to ensure safe operation. First, fiberglass reinforced polymers. High mechanical strength and durability. Second, thermosetting plastic. High heat resistance and do not melt easily under fault condition. Third is ceramic materials. Excellent electrical insulation and withstand very high temperatures. Safety purpose of circuit breaker. First, prevent electrical fires. Stop overheating and short circuit from causing fire hazards. Second, insulate live parts. Covers energized components to avoid accidental contact. Third, shock and heat protection. Protect user from electrical shock and shield internal parts from high temperatures. Key features of circuit breaker. First, high dielectric strength. Can withstand high voltage without breaking down. Second, heat resistance. Materials remain stable under extreme temperatures. Third, impact durability. Strong enough to resist mechanical damage and external forces. And last, focus on protection and durability. First, robust housing. Top outer casing ensures safety in harsh environment. Second, long-lasting insulation. Maintain performance over time without degradation. And last, reliable performance. Ensure consistent operation and protection of electrical system. The insulation and housing of a circuit breaker are essential for safe operation, fault protection, and long-term reliability. By using heat-resistant and materials, circuit breaker can protect both electrical system and human life even under extreme condition.
Next is type of circuit breakers. Number 1, MCB or miniature circuit breaker. Number 2, MCCB or molded case circuit breaker. Number 3, air circuit breaker or ACB. And number 4, oil circuit breaker. And lastly, number 5, SF circuit breaker. What is MCB or miniature circuit breaker? A miniature circuit breaker is an electrical switch that automatically switches off the electrical circuit during an abnormal condition of the network, meaning an overload condition as well as a faulty condition. Next is MCCB. A molded case circuit breaker is a type of electrical protection device that is used to protect the electrical circuit from excessive current, which can cause overload or short circuit with a current rating of up to 2500 ampere MCCBs can be used for a wide range of voltages and frequencies with adjustable trip setting. These breakers are used instead of major circuit breaker in large-scale photovoltaic system or PV system for system isolation and protection purposes.
So our topic it's all about high voltage breaker. So in the picture, as you can see, the first is about air circuit breaker. So air circuit breaker operates by using air as the medium to extinguish the arc formed during circuit interruption. So it is widely applied in low to medium voltage systems, particularly in industrial distribution panels. So it means advantage include simple constructions is easy to of maintenance and cost efficiency, although its performance is limited in very high voltage applications. So next picture is oil circuit breaker. So oil circuit breaker utilizes insulating oil to both cool and extinguish the arc. So the oil also provides excellent insulation between contacts, making it suitable for high voltage operation. So, however, it poses safety risks such as fire hazards and requires frequent inspections and maintenance, which is limits its modern usage. So, the third picture is SF circuit breaker. So, SF circuit breaker uses sulfur hexafluoride gas, known for its superior insulating and arc quenching properties. So it is highly effective in high and extra voltage transmission systems. So this type of breaker ensures fast and reliable operation. So but its drawbacks include high cost and environmental concerns due to the gas usage. The fourth picture is vacuum circuit breaker. So a vacuum circuit breaker interrupts current within a vacuum environment where the absence of gas prevents sustained arc formation. So it is commonly used in medium voltage applications and is recognized for its highly reliability, long service life, and minimal maintenance requirements. So the last picture is application in power systems. So application in power systems, circuit breakers play a critical role in power system protection. So they are designed to automatically interrupt the flow of current during abnormal conditions such as short circuit and overloads. By doing so, they help protect electrical equipment, ensure system stability, and enhance overall operational safety in residential, commercial, and industrial installation. So the next slide is application and importance. So first in the picture is all about residential application. So residential application shows a residential electrical panel where circuit breakers are installed in residential settings. So circuit breakers are used to protect household wirings and appliances from electrical faults such as overloads and short circuits. So when a fault occurs, when the breaker automatically interrupts the flow of electricity, preventing potential hazards like fire and equipment damage. So this ensures the safety and reliability of electrical systems inside the home. So the next picture is all about industrial applications. So the second image shows circuit breaker used in an electrical settings where multiple breakers switches are installed a control panel. So in industries, these breakers are responsible for managing and protecting heavy electrical loads such as motors, machines, and production equipment. So they ensure that in case of faults like overload or short circuit, so the power supply is immediately disconnected to prevent equipment damage and workplace hazards. So these applications is essential for maintaining safe operations, minimizing downtime, and ensuring continuous production in industrial facilities. So the last picture is power distribution substation application. So the third image represents a power distribution system, specifically a substation with high voltage circuit breakers. So in these applications, circuit breakers are used to control and protect the flow of electricity across transmissions and distribution lines. So they play a critical role in insulating faulty sections of the network during disturbances. So ensuring that the rest of the system continues so to operate normally. This helps maintain system stability, reliability, and continuous power supply. So circuit breakers have its own advantages and disadvantages when you're using it in an electrical system. So first, what are the advantages of using a circuit breaker? First is its reusability. The one major advantage of using a circuit breaker is that they are reusable. Unlike fuses, which must be replaced once they blow, a circuit breaker can simply be reset after it trips. This makes the circuit breaker more convenient and cost-effective over time. Users do not need to keep spare replacements, and downtime is minimized since power can be restored quickly. Another advantage is that it has better protection. Circuit breakers provide reliable protection against electrical faults such as overloads and short circuits. An overload occurs when too much current flows through a circuit, while a short circuit happens when current takes an unintended low resistance path, because that's where electricity wants low resistance paths. So circuit breakers automatically disconnect the electrical supply when these unsafe conditions that I have mentioned have occurred. They help prevent equipment damage, they reduce overheating, and they also lower the risk of electrical fires. Another advantage is its ease of operation. So circuit breakers are easy to operate because they can be manually switched from on to off. This allows them to function not only as protective device but also as control switches during maintenance or repairs. Technicians can safely isolate parts of the electrical system without removing components, making troubleshooting faster and safer. And another advantage is its safety. So the safety is important when installing electrical systems in either residential or even industrial. So circuit breakers are enclosed systems designed to reduce exposure to live electrical parts. This enclosure minimizes the risk of electric shock and protects users from sparks or arcs that may occur during fault conditions. Because of this built-in safety structure, or feature rather, circuit breakers contribute to a safer electrical environment in homes, school, and also industrial facilities. So now, as I have mentioned the advantages, there are also disadvantages of using a circuit breaker. Pero syempre, mas marami advantage nun kaysa sa disadvantage. So ito na nga, although circuit breakers provide many benefits in electrical protection, they also have some disadvantages that should be considered when selecting protective devices for electrical systems. So first is the higher cost. So one of the main disadvantages of circuit breakers is their higher cost compared to fuses. So circuit breakers contain more complex components such as trip mechanisms and arc control systems. These parts make their design and manufacturing more complicated. In addition, installation may also require more effort and proper setup. Because of this, circuit breakers are usually more expensive, especially when used in simple or small electrical circuits where a fuse could be more sufficient than the circuit breaker. So another disadvantage is its possibility of failure. Another disadvantage is, as what I said, the possibility of failure. Circuit breakers have both mechanical and electrical components that can wear out over time. So frequent switching, environmental conditions, and poor maintenance may cause these parts to degrade. When this happens, the circuit breaker may fail to trip during a fault, or it may trip unexpectedly even when there is no problem. This can lead to equipment damage, system interruption, or safety risks if not regularly inspected and maintained. So lastly, another disadvantage is the maintenance required. So another disadvantage is that circuit breakers is that they require regular maintenance to ensure proper operation. So unlike simple fuses, circuit breakers have mechanical moving parts and internal contacts that can accumulate dust, corrosion, or wear over time. These conditions may affect faults, so regular inspection, cleaning, and testing are necessary to confirm that the circuit breaker is functioning properly. This maintenance requirement can increase the operational effort and cost, especially in large electrical systems with many circuit breakers.
Now let's discuss some important safety tips when using circuit breakers. First, proper installation is very important. Circuit breakers should always be installed according to electrical standards and manufacturer guidelines. If they are installed incorrectly, they may fail to operate during a fault, which can lead to serious hazards such as electrical fires, equipment damage, or even injury. That is why installation should be done carefully, preferably by a qualified person. Second, regular inspection and maintenance are necessary to ensure that the circuit breaker remains reliable over time. Components inside the breaker may wear out, or dust and corrosion may build up, which can affect its performance. By inspecting it regularly, we can detect problems early and prevent failures. Third, routine testing is also important. This ensures that the circuit breaker will trip properly during overload or short circuit conditions, which is its main function. Lastly, we must avoid overloading circuits. Although circuit breakers are designed to protect the system, repeated overloading can weaken them and reduce their lifespan. Proper load distribution and selecting the correct breaker rating are essential to maintaining a safe and efficient electrical system. Now for the conclusion. To conclude, circuit breakers are essential components in an electrical system because they provide protection against overloads and short circuits. They function as automatic switches that detect faults and now immediately interrupt the flow of electricity, helping to prevent damage to equipment and reduce the risk of fire. Throughout the presentation, we discussed their basic function, historical development, and main parts, such as contacts, arc extinguishers, and trip units, which all work together to ensure safe operation. We also explained how circuit breakers operate, including how they handle and extinguish electrical arcs during interruption. In addition, we look at the different types of circuit breakers used in various applications, from residential system to industrial and high voltage power distribution. Each type is designed to meet the specific needs but all share the same purpose of protection. Even though circuit breakers may have some disadvantages, such as higher costs and their need for maintenance, their advantages, like fast response, reliability, and reusability, make them very important. Overall, circuit breakers play a critical role in ensuring the safety, reliability, and efficiency of electrical systems, and proper usage and maintenance help ensure their long-term performance. That's all.